Hello everyone, welcome to Radiatic. In our previous lecture, we discussed how scientists discovered the structure of the atom and now the model evolved from single idea to the modern quantum mechanics model. Now we know that an atom has a small dense nucleus containing proton, neutron and electron. Proton and neutron is containing in that nucleus and electron present around the nucleus. But understanding the structure alone is not enough. In the radiation physics, we need to answer some important questions like how do we differentiate one atom from another? Why does one atom remain stable while another release radiations? The answer comes from understanding atomic number, mass number, isotope concepts and electron arrangements. So, atomic number is the most important property of an atom because it defines its identity. The nucleus contains positive charge particles like protons and number of proton is fixed for a particular element. If the number of proton changes, the atom becomes a different element, means changing only one proton completely change the identity of an atom. So atomic number is not just a number, it is a fingerprint of an element. In the neutral atoms, the number of electron equal to the number of proton because positive charge and negative charge balance each other. That we atom that's why atom is electrically neutral. So that we understand the property and the behavior of an element. Whereas atomic number tells which element we have, but nucleons or nucleus contains not only proton, it also contains neutron. Both proton and neutron are called nucleons because they present inside the nucleus. The total number of nucleons give the mass number. But do you know, mass number does not represent the actual weight of the atom. It represents the total counts of heavy particles inside the nucleus. When the neutron number get change while number of protons remain same or constant, this create different from forms of the different same element, that is called as isotopes. Now we come to one of the most important concept in radiation physics, that is isotopes. Sometimes atom of the same element does not have same number of neutrons. When number of protons remain unchanged, then their chemical identity remains same. But when the number of neutron will change of the same atom, there will be change in nuclear mass and stability. These different nuclear forms of the same element called as isotopes. Many radioactive sources used in medicines are isotopes because unstable isotopes release radiation to become stable. After understanding the nucleus, we now discuss about electron. Electrons are not randomly distributed around the nucleus. According to quantum mechanics, electrons exist in a specific energy state called as orbitals. The arrangement of electrons follow three important principles. Number one is Aufbau Principle. Aufbau Principle or Aufbau is a German word meaning building up. It states that electrons first occupy lower energy orbitals before moving to higher energy orbitals. Its nature always preferred the minimum energy conditions, therefore electrons fills the most stable available positions first. Number two is that Pauli Exclusion principle. It proposed by Wolfgang Pauli. It states that no two electrons in the same atoms can have exactly the same set of four quantum number Because of this principle, each orbitals can contain maximum 2 electrons. These 2 electrons have different spins, that is up spin and down spin. The principle explains why electrons arrange themselves in different orbitals. Number 3 is Hund's rule. Hund's rule, it explains how electrons fills orbitals having the same energy. Electrons prefer to occupy separate orbitals first before pairing. This arrangement reduces electron-electron repulsion and increase the stability. Now we connect atomic structure with radiation physics. Inside the nucleus, two opposite effects exist. Protons have positive charge, so they repel each other, but nuclear force hold proton and neutron together. For a stable nucleus, these forces must remain balanced. If neutron and proton balance become unstable, the nucleus become unstable. The unstable nucleus release energy in the form of radiation. This process is called as radioactive decay. Therefore, radioactivity is not a random process, it is result of nuclear instability. That radioactivity we will discuss in detail in next upcoming video. Thank you so much for watching Radiatic.